Welcome to, sorry about that, welcome to week 4, which is algorithm and problem solving. Now, a little bit recap of what we did last week, which was week 3. It was more of data structure, dealing with lists and dictionaries, and topics we covered were the lists, the index, dictionaries, and then crude operations. Um, And then for this week is algorithm and problem solving. Now, the hooks for the week is how does Google find results in milestone? How does it do that? Now, topics we'll be covering under this week is algorithms, searching, sorting. Then we'll look at some big picture problem solving. But then this will be more in details when we have the one-on-one session. But for this, it's gonna be more of theory. Now, a little bit of what we did last week, that I guess I did not bring up here. So we have some things. Let me put this in last week. Now, let me try to zoom this. So we actually have something. Um, I did not really bring up this, but this also has to do with week 3, which has to do with list or dictionaries. Now, there's something that you can do with list. Now, remember that we're able to get the contact. I mean, get some data within a collection called contact. Now, probably let's call it anything rather than contact. Let's just do fruits. Now, we have this. We have apple. We have banana. We have cherry. We have date. Now, these are fruits. One thing you can do that I did not mention last week is being able to manipulate this information. Now, remember that this is an ordered collection of data. It is in an order. And remember the indexing we spoke about. Now, one thing you can do is you can manipulate the information here. Now, what does that mean? We have some common things with uh, that you can do on a list. The first one is the pop, then we have the push, then the slice. These are the common things you will be able to do with uh, a list, how you can manipulate. Now, let me quickly explain the pop. Remember our indexing. Sorry, instead of contacts, I want us to be using fruits because this is what we are manipulating. And then the same thing here, but then we'll take it one at a time. Now, when we talk about pop, the terminology pop is to remove a particular data, but we are using the index, remember. So we have 0, 1, 2, 3. So with this, let's quickly check out which of the data was removed. And let me run this. What happened? It ran into an error. Python command not found. Okay. Mm, Let me exit this. Let me try to run again. What compiler am I actually using? Um, permit me. Um, okay. Something is wrong somewhere. No, somehow, somewhere, I can't do that. But let me do it from here. Python 3 in week week 3.5. Let's see how this goes. Oh yeah, it's run. So what this does is what we try to do is we remove an item. Now if we are to go back and print fruits, uh you believe me that one of the item is gone, and the first time we tried to pop to show which of the item, and we noticed that it was index 1, which was banana. So that's what you can do. You can manipulate and remove whatever it is using the pop function. Now, but the rule behind it is you have to call the variable and then dot pop then with the index. This is an inbuilt function, so you can use it to remove an item from a list. Now, another thing we can do is we can push. Now, push is to append, and what that means is we are adding. So, from the list here of fruits, you can add another fruit, but then it doesn't mean it's just fruit. I can add anything to the list, but then since we are working with fruits, instead of putting a name there, let's add orange. So what that means is when you run it, an item has been added, it has been pushed. Now you notice that we use pop, we call pop here, and here we got a result. It doesn't work like that with push. We have to call the fruits, and yeah, sorry, we have to call the fruits, and that's what we will see. And then clearly you see that at the extreme end, uh, an item was added. So this is how you can manipulate this. Now that was for food. Now let's talk about slice. Let me run this. Mm, so let's try to slice the fruits and see what result we get. Now this holds in slicing is just more of getting items from the index so you can range it. Now what that means is I just need this item and then this item. So you get their index. This is index 0. This is index 1, 2, 3. So if I put 3 here, you know that our output is clearly going to be from this to this without this. So that's actually what all this does. Now that's about week 3 that I forgot to update. Now let's quickly, sorry, instead of PHP to Py, let's focus on what we have for week 4. Week 4 here we have is more of algorithm and problem solving. Now let me quickly explain some of those terminologies. Um, Algorithm is a simple, sorry, it simply means a step by step to set of instruction for solving a problem or completing a task. Is the procedure you use in solving a problem. That's what an algorithm is. You can use algorithm everywhere, every day without realizing it. Now we do use it, which is just common. You try to organize what you do, so it's a common thing. We use algorithm every day. Now, in programming, a good algorithm must be clear and unambiguous. Every step is precisely defined. A good algorithm must be efficient. Now, it solves the problem using the least amount of time and computer memory possible. Now, you remember that we tried something with loop, and the loop was an infinity loop, so it will break your system. That's not an efficient way of writing code. Now, but with algorithm, you have a, a clear and unambiguous, uh, effective uh, code, and then it must be efficient as well. So let's quickly run to search. Now, this will be more of definitions, but then we will use it on the later, um, at the long run. Then search algorithms are used to find a specific targeted item within a collection of data, like finding a contact in your phone or a video on YouTube. At the beginning level, you use cover two main types. So sorry about that. Now we have basically under search, we have basically uh two main types of search. The first one is linear search, and then the next one is binary search. You look at every single item, that's for linear search, in a list, one by one, from start to finish, until you find what you need. Is slow but works on sorted list. Now that's linear search. The binary search, a much faster method that only works if the list is already sorted. It looks at the middle items, cuts the list into half depending on whether the target is higher or lower, and then repeat this repeat this on and on. This is how Google or a physical dictionary search works so fast. Now the next one we have, please today will be more of just definitions. Now the document will be sent and then you will get more of this. Now the next one is sorting. Sorting is the process of arranging data into a specific order, either alphabetical order or numeric order from smaller to larger. Now, computers need sorting data because, as mentioned above, algorithms like binary search require data to be sorted to work. Now, common beginner sorting algorithms include bubble sort, selection sort. Now, we'll get that deeper. Now, the next one is just looking at the bigger picture. Before you write a simple line of code, you have to break down the problem. This topic teaches you how to think like a programmer using a few key steps. Decomposition, that's breaking a massive uh, intermediate problem down into tiny uh, manageable steps. Pseudocode, writing out your algorithm in a plain English before translating it into actual code sentence. Then each case is thinking about what could go wrong. What if the user search for a name that does not exist in our data? Now, this topic carries almost everything we have been doing, from variables down to loops, down to data structure, down to list dictionaries, and then from what we had, the pop and the push, the slice. Now, that's where our algorithm works. Now, we will be using most of this, just to be able to explain that better. Um, Now, I only defined these topics. It was more of a definition. I only defined them, and then there is going to be no practical to solving this. But then think of this: search a name in a database. How does it work? Now, from week three, we have this. Now, using search algorithm, if I ask you what's the index for Apple? It's as easy as possible because this list contains just a fewer data, value within the variable, and you can easily get the position of Apple. Now that's what search does. But then in a more technical way, when you come to think of it, uh, using the types of search we have, which is linear and then binary search. Now, linear, that was where I said you can easily know that this is Apple and this is where to get it. But when you're using binary, you have to divide this equation into two. You first search the first half. If it's not there, you go to the second. So that's basically what that means. And yeah, so that's about this. So let's see how best we can jump into some things. Uh, I think I'll leave this for now. Then we'll talk more about this and how to use it. Thank you.